All right. Give me a second. Ta-da. Which one? This one. Okay. So welcome back, Math 3. We are going to continue where we left off in 3.8, which was the addition/subtraction equality property of equality. So solving equations, the addition property. It's also known as the subtraction property. You can call it either of those two things, because if you see one, you're supposed to do the other. So we talked about how to solve an equation. You want to be working in opposites. And you want to isolate your variable. Your goal is to solve to get x equals. And it doesn't matter which side of the equation the x is on. It can be the left or the right. But it has to say x equals a number. And then we said, all right, well, if you see an addition, you're supposed to subtract. If you see a subtraction, you're supposed to add. But you focus on the side of the variable. You don't even look at the side without a variable. And very often through these problems, I was scribbling out numbers that we shouldn't even be looking at initially. So like in A, we saw x plus 7 equals 23. So we only focused on the x plus 7 side. Because that was a plus 7, we subtract 7. But then that other rule is whatever you do to one side, you do to the other. So we can't just subtract 7 on the left side. You have to do it on both sides. Remember, our goal here is to simplify the side with the variable. Now, equations don't just have to have a variable on one side. It can be on both sides, just as a warning moving forward. And we did several different examples, and we want to do some more. So let's pick up where we left off with, that says C and F. That should probably be C and D. They make silly typos. Nobody's perfect, right? Okay. So let me zoom in just a little. Y plus 27 equals negative 54. Make sure I'm on black. There we go. Got it. All right, so y plus 7 equals negative 54. Again, I'm only focusing on the left side. I'm not even going to look at the other number right there for a minute. I'm only focusing on the left side because that's where the variable is. It says plus 27, so we're supposed to subtract 27 on both sides. Alrighty. Come on, you can do it, computer. All right, so we bring down our y. Make sure you bring down the stuff that doesn't get adjusted. The 27 minus 27 cancel. That's the whole goal of this, is to cancel whatever is on the side of the variable. We bring down our equals. And the negative 54 minus 27, well, that's the same thing as negative 54 plus negative 27 if you need to do the rewrite. That's SAK, same add keep. 54 plus 27 is 81. But they're both negatives, so that should be a negative 81. So many people will miss the sign. They'll do the addition or subtraction correctly and then just forget the sign or not learn their rules. It is important. You have to have that down. Next up, for a plus 76 equals 76. Now again, I'm not even looking at the number by itself. I'm only looking at numbers on the side of the variable. And that says a plus 76. So I should probably, let me hit undo. Undo, please undo, there we go. Because that says a plus 76, I want to subtract 76, but not just on one side, on both sides. Let me zoom in a little so I can just make that look a little neater. Okay, there we go. So on the left side, we didn't change the A, we bring it down. The 76 minus the 76 cancel. We bring down our equals, and then you do your math on the right side. 76 minus 76, well, that's 0. No, nobody said you can't have 0 as a solution to an equation, and if you check it, 0 plus 76 is most certainly 76. That's it. Equations are all about unraveling the problem. They're about working in opposite operations, and we said that addition and subtraction are opposite operations. Now, they're not always just one step, though. Very often, and by the way, I said it earlier, but I didn't have it typed till here. This is 3.8 continued. You can see it very small up here. Ignore where it says repaired. That was from losing power from the wind. Yay, that was fun for a couple of days, practically, as some of you already know. So when we get to this problem, these problems, they say solve the equation using the appropriate property. Honestly, you don't need any of those instructions besides solve the equation. There's nothing inherently different about this problem in terms of a goal. We still want to get this down to x equals. But you can see this is a bigger looking problem. There's more going on. It's not just a single x on one side. There's two of these x's on one side. It's not just a single number on the other side. It's two of them, and then plus the number here. And I didn't literally mean plus, I mean in addition. So you don't want to necessarily start trying to move things from side to side first. If you can, CLT, combine like terms, combine like terms. If you only look at one side of the equation, so let's just narrow our field of vision to this. Ignore the 19 minus 3. If you only look at one side, if anything is simplifiable, whether it's combining like terms or maybe even, spoilers for B, distributing, do that before you start trying to move things from side to side. Oops, don't need to erase that. So on this left side, we have a negative 43x plus a 44x. Those are like terms, so we're going to combine them. The negative 7 stays. There's nothing like it. The equals will stay. And the negative 43x plus the 44x, well, negative 43 plus 44 is positive 1. So that's a plus 1, but they have an x, so we keep the x. Now, I don't actually have to write this 1, and in the next step, I will get rid of it, because 1 times anything is anything. 1 times 5 is 5. 1 times apple is apple. 1 times x is x. Pardon me for a second. Now, on the right side, so now we're just focusing on this, 19 minus 3 is combinable. Those are like terms. 19 minus 3 is 16. So again, I'm just going to rewrite this. Negative 7 plus x. I don't really need to see the 1 equals 16. Now, there's no more like terms on the left. There's no more like terms on the right. This is where we generally have to start moving things. Now, what somebody might say is, oh, this is a plus in front of the x, so I need to subtract 7 on both sides. That would be wrong. This plus sign is not what we're looking at to determine what to do. It's the sign associated with the 7. So because that says a minus 7, we need to add 7 to both sides, which will give us the negative 7 plus the 7 will cancel. We bring down the x. I don't need to write the plus sign in front of the x anymore because there's nothing in front of it. It's unnecessary. Bring down your equals. 16 plus 7, add to 23, and that is your answer. For B, and I already kind of hinted at this, I spoiled it earlier. We said if you see any like terms or distributions on the same side, to go ahead and do that first. Okay, so again, distribute and or combine like terms first. So right now, if I only look at the left side, I don't see any like terms. But Mr. Beckner, I do. I see this x here and this minus x here. Okay. But the problem is this x is inside of parentheses, so you can't combine it with the minus x outside of that one because of PEMDAS. So what we need to do is distribute the 2 to the x and to the 5. 2 times x is 2x. That just means 2 times x. There's literally nothing being done to that. And then there's a minus symbol. The 2 times the 5 is a 10. Then we bring down the minus x and the equals and the 8. So we distributed the 2 in the front of the parentheses. Why? Because that's the only thing we could do. Now you might want to start moving things around, but I would say it's a bad idea because there are like terms. This 2x and this minus x are like. So we want to combine our like terms. 2x minus x. Now remember, there's an imaginary little 1 in front of that. If you need to see it, here it is. So 2x minus 1x, 2 minus 1 is 1. So that's a 1x. Keep the variable the same. 2 apples minus 1 apple is 1 apple. That's what that says. Bring down the minus 10, bring down the equals, bring down the 8. Now again, I don't need to see this 1, so I'm just going to rewrite this without it. Now we're ready to move things from side to side. On the variable side, we see a minus 10, so we're going to add 10 to both sides. 8 plus 10 being 18. We bring the x down, the 10s cancel, bring the equals down. There's our 18, and there's our answer. Okay, let's try another one. Please scroll. Please scroll. Thank you. Swear all my technology is being terrible today. I'm going to blame the power outage. So, yeah, we'll do both of these in the interest of the more complicated problems. That's not an issue. So, combine like terms, distribute whatever you see that you can do. Focusing on the left side, I see a 7 with a parentheses, so we can distribute that. And that's all we're going to be able to do for now. So we're going to distribute the 7 to the x and the 5. 7 times x is 7x. Then the plus symbol. 7 times 5 is 35. Bring down the minus 6x. Bring down the equals. And in the interest of only doing one thing at a time, one type of thing, so I just distributed. I'm only going to do the distributions. Yes, I could have technically simplified the 14 minus 31. I could have gone ahead and done that. In fact, let me at least go ahead and change that to adding a negative. So 7x plus 35 minus 6x equals 14 plus negative 31. So again, I could have combined the like terms on the right side because they were completely separated from that distribution. But I'm just going to only do one type of step at a time. So now we will CLT, combine like terms. On the left side, we got the 7x minus the 6x. 7 minus 6 is 1. So that makes a 1x. I'm going to skip writing the 1 this time since we've now seen it 3 times. So that's x. Again, that's combining the 7x and the minus 6x. We bring down our plus 35. We bring down our equals. And then we got 14 plus negative 31. That's DSL, different, subtract, keep the sign of the larger. 31 minus 14 is going to be 17, but the larger number is negative, so we got to make that negative. Subtract and keep the sign of the larger. Now we're ready for our algebra. We got x plus 35. The 35 is what needs to move. It's being added. So we'll subtract 35 on both sides. Bring down our x. The 35s will cancel. Bring down our equals. If you need to rewrite the negative 17 minus 35 as negative 17 plus negative 35, be my guest. Again, not everybody does the rewrites once they hit the algebra. That's up to you. But you're going to have to understand that these are the same thing because a lot of algebra teachers, again, will no longer rewrite it this way moving forward. So SAK, same, add, keep. 35 plus 17, what's that, 52? But they're both negative, so we keep the sign and make it negative 52. Finally, D, once again, I'll only try and do one type of thing, simplification at a time. I see like terms on the left, but I see a distribution on the right. You could go ahead and combine the like terms on the left if you want, and then the distribution. But spoilers, after your distribution on the right, you're going to end up with like terms. You're going to end up being able to combine whatever this number becomes. I'm sorry. I highlighted the wrong thing. We're going to be able to combine whatever this thing becomes, which will be a 3x, along with that thing, the minus 2x. So I'm going to distribute first. It's usually better to distribute first. I'm not going to say it's always better, just usually. So we'll leave the 4 plus negative 21 alone, which is the same as 4 minus 21. Distributing the 3 gives us 3x minus 3. 3 times x is 3x. 3 times a negative 1 is a negative 3. Bring the minus 2x down. Now we will combine our like terms. On the left side, undo, we got the 4 plus a negative 21. Those are DSL. 21 minus 4 is 17. The larger, that's a positive 4 and a negative 21, so that's going to stay negative 17. Keep the negative, keep the larger number sign, that is to say. 3x minus 2x is 1x, but again, 1x is just x. As a reminder, 1x is equal to x. So the 3x minus the 2x, there's really a 1 there, but we just don't need to write it. Then we bring down the minus 3. Now we're ready to move things. The minus 3, we can add 3 to both sides, because that's our variable side. The negative 17 plus 3, once again, DSL. I told you this book loves DSL. Different signs, subtract, keep the sign of the larger. 17 minus 3 is 14. The larger number being negative. Keep the equals, keep the x, cancel the 3's, and we get x equals negative 14. And that, my students, is our answer. Remember, if you don't trust these, you can always go back and check them. And I highly encourage that, especially while you're beginning this. If a student's done 50 or 60 of these accurately, I'm not going to say they need to check every one. If you're getting every other one wrong in your homework, or you're taking a quiz and it takes you 3 or 4 attempts to do a quiz, check your answers. Can only do you good. So again, in algebra, when we're trying to move things away from an x, when that's our goal, be goal-oriented. When we're trying to move things away from the x, you work in opposite operations. And we said addition and subtraction are opposite operations. There were still some distributions. There were still combining of like terms. It depends on the complexity of the problem. And you need to handle those things before you try and move things from side to side. All right. 3.9, next section. Solving equations, the multiplication property. So the last section was the addition property, and what we ended up saying was, if you have x plus a number, you need to subtract that number on both sides. If you have x minus a number, you need to add that number on both sides. We are going to apply that same principle to the concept of multiplication and division. So multiplication and division are opposite operations. So down here, I'm going to go ahead and have my, in my opinion, better, slightly less wordy version of this. Multiplication and division are opposite operations. So if your variable is doing 1 to a number, to undo it, then do the opposite to both sides. In other words, if you see a multiplication, then divide. If you see a division, then multiply. Oop, that got squirrely. Let's try that again. So once again, this is my version of it. And you might say, well, that's a little more wordy. Well, you can just focus on the, if you see a multiplication, divide. If you see a division, multiply. That's the real bread and butter of this. If you see a multiplication, then you divide. If you see a division, then you multiply. Those are your opposite operations. Now, you're not always going to see literally, say, 3 times x. You might just see 3x. Remember, a number next to a variable implies multiplication. You might not see x and then the division symbol and then 5. You might just see an x on top of 5. And remember, fractions count as division. So let's try out. In fact, there's only 6 of these, so we're going to do all of them. Another short section. Solve the equation using the multiplication or division property of equality. So for 9x equals 45, that is 9 times x equals 45. So again, this is 9 times x. So to get rid of the 9 times, I don't really care what this 45 is for the moment. I'm only focusing on this numbers with variables. So that's 9 times x. So what we do is we divide both sides by 9. And this is how we like to write this. It's not the only way to write it. It's just, in my opinion, the best way to write it. Okay, so why do we do this? With the addition and subtraction problems, we wanted things to cancel and make a 0. So in the past, we had something like x plus 5 equals 7. And we need to get rid of the plus 5, so we subtract 5 on both sides to make it 0. Again, 5 minus 5 is 0. That's the goal with addition and subtraction. We don't want to make a 0 here. What we want to make is a 1, because 9 on top of 9, 9 divided by 9 is 1. So these cancel. It's the same number top and bottom on a fraction. They cancel. You can write a little 1 here if you like, so that makes this a 1x. But we've talked about numerous times already that 1 times x is just x. So for multiplication and division, we don't want to cancel and make a 0 because that would make the x go away. We want to make it a 1 because then it'll just say x equals. And on the right side, you're doing whatever product or quotient you have to. 45 divided by 9 is 5. So x is equal to 5. And that's the whole thing. I did not subtract 9 on both sides. First of all, subtracting 9 on both sides, 9x and 9 would not be like terms. You would not be able to subtract them. But you can divide 9x by 9 because the 9s will cancel. You can divide it by any number you want, but that's the best number to divide it by, so you get that cancellation. Let's look at problem number 2, and I'm gonna rewrite the original problem just for the sake of space, like so. So on the left side now, again, I don't care about a side that's just a number and doesn't have a variable. I don't want to look at that. It might just confuse me. So the variable is dividing by -2. The opposite of dividing is multiplying. So we're going to multiply both sides by -2. And this is how you would show that. Here's my -2 times the left side. Here's my -2 times the right side. Now, if there's no negatives, you don't necessarily need parentheses, but oh boy, do we have negatives. So I could have just done a dot if these were positives. Now, I didn't just multiply by +2, I multiplied by -2. So let's see why we did that. Well, we've said in the past we need to use the exact same number. This is a -2 that's being divided, so that's why we have to multiply both sides by -2. Let's see what happens. We had a -2 in the top, a -2 in the bottom. Well, 2 divided by 2 is 1. And guess what? A negative divided by a negative is a positive. So all those -2's cancel. The only thing we see left over is our b, the 1b. Again, there's a 1 there that I'm no longer going to write. And on the right side, we get whatever math we have to do. 2 times 19 is 38. But those are the same signs that the answer is positive. Remember, the rules for multiplication and division are vastly different from addition and subtraction. You've got to practice this 10 quintillion times, or however many you need to, until you get this right every single time. You don't get to make mistakes. If you think you're going to practice this for 5 minutes and have it down, most of you are severely mistaken. Hours of practice need to be made. Number 3, -7 times m equals positive 98. So again, I don't even care what that number says because there's no variable with it. There's no math to do on it. I only care about the -7m. What's -7 times m? So to get rid of the -7 times, we have to divide. Now I'm going to do this one wrong for a hot second. I'm going to do this wrong temporarily. Wrong temporarily. I'm only going to divide by 7. Again, this is wrong temporarily. I will fix it in a minute. So I see the 7, so I divide by 7. I'm rushing. I got to get this done right now. I'm not really worried about whether it's right or wrong. Ha, 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 ha. So what happens here? The 7 will divide the 7, but now we have a negative divided by a positive. Those are opposite signs, O-N. Opposites result in negative numbers. So that says -m equals, and then the right side is whatever number it happens to be. I'm not even going to focus on that for now. This right here is the problem. That does not say m equals. It says -1 times m equals. That is -1 times m equals whatever. So that is why we have to multiply or divide by the exact same number, including its sign. There we go. One more. There we go. All right. So instead of dividing by +7, let's divide both sides by -7. Because -7 divided by -7 is a +1, leaving us with just the m. And on the right-hand side, well, let's see. 7 would go into 70 10 times, and then into 28 4 times, so that's 14. A positive divided by negative, those are opposites, so the answer is negative. So the answer is -14. Please be careful. Those little sign mistakes, you're not getting partial credit for something like that in a course like this. It's right or it's wrong, especially if it's one step to find the answer. You have to have your sign rules down. And a lot of people go, oh, okay, well, I'm just going to rely on my calculator. Your calculator is not telling you what specifically to do here, so that's not going to help you. Yes, your calculator can do the 98 divided by the -7, but it doesn't tell you inherently what to do and how it will cancel. All right, number 4. Now we got time. Okay, number 4, y divided by -26 equals 0. So again, not even focusing on the equals 0 side, just the y divided by -26. Well, that's a division. The opposite of division is multiplication. So we got to multiply both sides. Again, in the interest of room, I'll rewrite the equation. So I know I got to multiply both sides by a number. What number? Is it just 26? Would this be good enough? Well, the 26's would cancel, but that's a positive and a negative on the left side, so the negative is stuck. So no, that's not good enough. I need to multiply both sides by -26. So that -26 divided by -26, it's +1. They cancel completely, leaving us with a 1y, also known as just y. On the right side, anything times 0 is, well, this is difficult, 0. Not undefined, not does not exist, it's 0. That was weird. I had a noise and I don't know why. Okay. All right, distraction aside. Back to it. Number 5. -435 equals 29t. Now again, a number and a variable sitting next to each other implies multiplication. So that means we need to divide both sides. Again, I don't care what that number is. I only care about the 29. So we got to divide both sides by 29. Now remember, you are allowed calculators at this point, whether or not I like that. Technically for the whole chapter, arguably, since it's a combined test, you're allowed calculators the whole time, but you still need to learn the rules without a calculator. If you can't do this stuff without a calculator, with the simple numbers, you're going to have problems moving forward. Use a calculator to check your work, not to do your work. Use your brains, exercise your brains. But again, you have calculators, so the 435 divided by 29. You do the long division if you need to, but in the interest of time, that comes out to 15. But a positive and a negative dividing each other, no matter the order, is a negative. The 29s will cancel, leaving us with just the t on the right-hand side. So -15 is t. And on the right side, I'm sorry, on number 6, r divided by 7 equals -16. Again, I don't care what the -16 is. I'm just looking at the r divided by 7. Division, the opposite is multiplication. So I know I need to multiply both sides. Give myself some space. So we're going to multiply both sides by the number paired with the variable, which is 7. So 7 times r over 7 equals 7 times 16. We do that so the 7's cancel. One's on the top, one's on the bottom. So we get r equals. And then we're going to do 7 times 16. And again, if you want to use a calculator for something like that, you can, but you should still be capable of doing that without a calculator. 10 sevens would be 70, 6 of them is 42, and 42 plus 70 is 112. All positive, so the answer is positive. And that is our answer. So there's nothing too crazy in this section, quite honestly. That's it. That's all we really see. You see a multiplication with your number and your variable, divide by the number paired with the variable. If you see a division with a number and a variable, multiply both sides by the number paired with the variable. If it was a negative, use the negative. If it was a positive, use the positive. That's the only thing that's really different versus the last section where we were adding and subtracting. Because if you saw an addition, you subtracted. If you saw a subtraction, you added. Those signs did change, whereas they don't for the multiplication and division. And again, this is all based around the principle of cancellation. Cancellation works differently for multiplying and dividing versus adding and subtracting. Alrighty. Well, let's move on to 3.10. And this is a pretty short section. As you can see, it's nothing too crazy. Ratios. Something that we have honestly studied already over and over and over back in chapter 1. A ratio is a fraction. But there are a couple of different ways to write out fractions. And there's an error written or drawn up in here in the third one. This a over b right here should be over here. Let me see if I can fix that. Nope, it does not want to let me do anything. How about this? Insert equation. Well, that might be a problem. Come on. Gotta love technology. All right, sorry it looks a little ugly, but I'm just trying to represent that there. So a ratio can be written several ways. You can use a word, the word to, T-O, not T-W-O, not T-O-O. This isn't an English class, but that is important. T-O. A to B literally means the same thing as A colon B, literally means the same thing as A over B. Can I do this maybe? All right. Again, ignore that little arrow thing. I can't delete it, unfortunately. I can't move it. Oh, I lied. There we go. So the fraction bar is what means 2. The colon here means 2. So these are all actually read the same thing. I'm not going to read this A colon B. I'm going to read A to B. I'm not going to read this as A on top of B. I'm going to read A to B if I want to imply it as a ratio. So ratios are divisions. They're fractions. They're all the same thing. So for 1, 2, and 3, it says to write the ratio in 2 other ways. So they're giving us one of the 3 ways, and we need to write the other 2. So for number 1, they wrote the word version 9 to TO 11. So that means we need to write the colon version, I'm sorry, not A. They actually gave us a number this time. 9 colon 11. So that's read as 9 to 11. Or we could use the fraction 9 on top of 11. So that's the 3 ways that ratio could be written. All of them, if we say it out loud, are still 9 to 11, 9 to 11, 9 to 11. For problem 2, they gave us the colon version, so we need to write the word version, 25, the word 2, spelled correctly, and then 13. And then we need to write the fraction version, 25 on top, 13 on bottom. How do I know which one goes top, which one goes bottom? The first goes top, the second goes bottom. Easy peasy. You okay, Rambo? Hold on, my dog is doing something. All right. The joys of being at home. Problem 3, 35 on top of 64, also known as, in fraction words, 35 to 64. Well, we need the colon version, so that would be 35 colon 64. We also need the word version, 35, then the word 2, 64. Doesn't matter the order I write them in, just have to get all 3 done. That's it. That's how we write a ratio one way versus another way. Now, if your ratios as a fraction are reducible, well, guess what? That's probably a good idea to reduce them. Neither of these problems were reducible, though. 2 and 3, that is. nor 1 when we wrote it as a fraction. But if you could, then you should. We're going to do some of these, but not all of them. Let's see, number 4. Let me give myself some space. That's not going to work, is it? Because that pushed C down. I'm going to have to zoom out. And let's put this on its own page. That'll be better. What's happening? It just does not want to give me enough space for C. I'll make it work. Okay. So we're doing 4. A survey in a group of college students showed that 28 college students preferred taking online courses while 42 students enjoyed face-to-face courses. This is so unbelievably relevant, I can't even describe it since we started face-to-face and are now online. Irony. Okay. So a survey said that 28 prefer online, 42 prefer face-to-face. Write a ratio, we're on A. Write a ratio of the number of students that preferred online courses to the number of students that preferred face-to-face. For the love of math, especially when you go into quantitative reasoning, and you'll hear me say this 10,000 times in there, use your words. Write out the words as a fraction or as a colon, whatever you need to do to make sure you get these in the right order. What do they want us to do? The number of students that preferred online to the number that preferred face-to-face. So we're going online, and I'm going to write it as a fraction, over face-to-face. So what was the online number? That was the 28. What was the face-to-face number? That was the 42. And that's our ratio, 28 over 42. Now you might say, all right, well, Mr. Beckner, earlier you just said you're supposed to reduce fractions. They didn't actually say to reduce it. So they really actually want 28 over 42 as the answer for this. But note, moving forward, we will usually reduce. So you'd say, oh, okay, well, 2 will go into both of those. 2 will go into 28 14 times. 2 will go into 42 21 times. And then, oh, 7 goes into 14. 7 goes into 21. So that'd be 2 over 3. So in my opinion, that's the better answer. But for these, they didn't ask us to reduce it. And trust me, that's never going to happen again for the most part. I don't want to say never. That is almost never going to happen again. You will almost always reduce your fractions. B, write a ratio of the number of students that preferred face-to-face to the number that preferred online. This is opposite order. This is face-to-face to online. So here's our words, face-to-face over online. Well, that just reverses the top and the bottom. So it's 42, which was the face-to-face, over 28, which is the online. So that's the only answer we really need here. But please note that if you reduce this, you'd get 3/2. Now here's where it gets much more interesting with C. They want us to write the ratio of students that preferred online to the number of students that participated in the survey. So we're doing online to the total number of students. They did not give us the total number of students. They said 28 online, 42 face-to-face. Well, I guess we can't do this problem, right? Lies. Now it'll let me do everything right. Okay. So the first thing we need to say is, well, what's the total? Well, all we got to do is add the face-to-face and online. The face-to-face being the 42, the 28 being the online. It doesn't matter the order you write 28 plus 42. 8 and 2 is 10. 2 plus 4 plus 1 is 7. So that would be 70. So 70s are total. So now we're supposed to go online to total. So our ratio is online on top of the total. I don't even care about the face-to-face for this ratio. Okay, so what was the number of online? That was the 28. What was the total? We just found it to be 70. So this would be 28 for the online over 70 for the total. And again, they didn't ask us to reduce, so that's arguably the answer. But if you did reduce this, if you took 2 into both of these, you get 14 over 35. 14 over 35. And then if you took 7 into both of those, you'd get 2 over 5. So I'm just putting the reduced answers for fun. Because again, moving forward, that's generally what you're going to need to do. So I'm going to leave example 5 to y'all. I'll at least give some of the answers. They ask for the ratio of gold to silver. I'll do that one. They say the gold is 46. That's 46 over, and then silver was 29. So that was gold over silver. I'll skip B because it says gold to bronze. So you'll just need to use the bronze number and the gold number. You'll skip the silver. See, they gave us 3 different things. We don't use all 3 of them. So I will skip B. I'm not going to give you that answer. It's definitely got a 46 in it. May even be the same answer as A, hint, hint, hint. All right, C, write the ratio of the number of gold medals to the total. So our goal is gold to total. So once again, we need to get the total. Let me write that somewhere else. Which is the sum of all 3, 46 plus the 29. So that was gold, silver, and then bronze was another 29. Let's see, 6 and 9 is 15. Plus 9 is 24. 4 plus 2 plus 2 plus 2, that's 6, 8, 10. So it's 104 total. So doing gold, which was the 46, over the total of 104. And again, that would reduce, but I'm not even going to give the reduced answer this time since I said I wasn't officially covering it. All right. Now let's actually get into official problems where we're going to write them in lowest terms. So write the ratio in lowest terms. This means to reduce. And again, 99, 95, somewhere like that, percent of the time, this is what we're going to have to do. So we're not just going to write the 58 over the 86. We need to divide these out. It's been a long time since I've shown the division part written out. Oh, wrong button. Draw. So let's see, 8 and 6, 8 and 6. Well, they're both even, so 2 probably goes into them. So let's try that out. Well, half of 58 is 29. Half of 86 is 43. 29 is prime, 43 is prime. Nothing goes into both of them besides 1, as far as we can take it. 26 minutes to 14 minutes. So we'll write the 26 on top of the 14. And I'll do the slash this time. So what number goes into both of these? Well, they're both even, so 2 at least. 2 will go into 26 13 times. 2 will go into 14 7 times. So let's rewrite this as 13 over 7 because I don't think anything goes into both of them besides 1. They're both prime. 1's the only number. Number 8, 45 to 100. So that's 45 on top of 100. They both end in a 5 or a 0, which means we can divide them both by 5. Slash it, show the division, show the answer, whatever you have to do to write this. 5 will go into 45 9 times. 5 will go into 120 times. And I'm pretty sure that the only number, that goes into 9 and 20 is 1. So I cannot draw a box right now. So 9/20ths would be our answer. The only way we can really complicate a problem like that is if you involve decimals, fractions, mixed numbers, anything like that. 10 in particular is the biggest pain in the butt. So we're going to do 9 and 10. 11 is really the same thing as 9, so we're going to skip that. Write the ratio in lowest terms with whole numbers in the numerator and denominator. Give some space. So you will originally, for number 9, write 0.16 over 0.64. But remember, fractions imply division, and fractions and divisions, we're not supposed to have decimals in the bottom number. We can only divide by whole numbers. That's going back to chapter 2. So we need to make the bottom whole. So the decimal needs to go right 1, 2 times, and then we do the same exact thing to the top. Whatever you do to the bottom, you do to the top, which makes this equal to 16 over 64. Then we can reduce this. 4 goes into both of these, 2 goes into both of these, but even better than that, we can do 8. Even better than that, you're good with your numbers, you will recognize that 16 goes into 16 and 64. 16 will go into 16 once, 16 will go into 64 4 times. So that's a final answer of a fourth. I could have divided by 2, by 4, by 8, and then done another division and maybe another division and still ended up at the same answer. I just did this in one step instead of 2 or 3 or 4. Number 10. I'm highlighting this one. What you need to do is write as a division first. And when I'm using this, I mean literally write it as a division symbol. Instead of writing the word 2, write the division. Instead of writing on top of each other, write the division. So that's 1 7/8. Then a division symbol, 1 2/3. So this is technically a fourth way to write out a ratio. The reason we need to do this is because we're dealing with mixed numbers, and we don't know how to divide mixed numbers. We don't know how to multiply mixed numbers. We know how to add and subtract them, but we don't know how to multiply and divide them. So what we need to do now is convert to improper. That's where you multiply the whole on the bottom and then add the top. 1 times 8 is 8. 8 plus 7 is 15. So that is 15 over, keep the bottom the same, 8. Then your division symbol. 1 times 3 is 3, plus the 2 is 5. So that's 5/3. Now we know how to divide fractions. We multiply by the reciprocal of the fraction after the division. And then we change to multiplication. Oh, I already said the multiplying part. Multiply by the reciprocal. So the division is going to change to a multiplication. That's still a 15 over 8. I'll show in red what I've changed. The division is now a times, and the 5/3 becomes 3/5. Again, this is a very specific type of problem. So I'm really writing out the steps. This is the only one that's honestly a pain in the butt. And then you can multiply in the normal fashion, reduce and multiply and reduce, whatever order you prefer. I prefer to reduce first. 5 and 15 will reduce. 5 will go into 5 once. 5 will go into 15 3 times. The 8 and the 3 are not going to reduce. The 3 and the 3 are not going to reduce because they're both on the top. So that's it. That's as far as we can take it. So multiply straight across. 3 times 3 is 9 over 8 times 1 is 8. And we end up with our answer of 9/8. That's our ratio. And I'm willing to bet that none of you guessed that that was going to be the answer. I certainly didn't, looking at the original problem. Again, this problem is significantly different than handling it with decimals or whole numbers. When you're dealing with mixed numbers, this is a cookie cutter approach to the problem. Write it as a division, a literal division. instead of 1 7/8 over 1 2/3. Because what on earth do we do here? That's why I chose to use the literal division symbol instead. Convert, multiply, how we know how to do, reduce as necessary. All right, got about 10 minutes. Applications, let's do a couple of these. We'll do a couple from 12, and then a couple from 13, and then we'll call it. So refer to the table that shows the standings of the first 7 NBA games for the regular 2012 to 2013 season of the Western Conference. Again, this really dates this book 8 years later, still using this information. It's fine. Find the ratio of the number of games won for the Oklahoma City team to the number of games won for the LA Lakers. So we're doing Oklahoma to Lakers. Oklahoma is right here. That's the 60. The Lakers are right here, right? No, you see the LA, but we're supposed to be the Lakers, not the Clippers. Hey, buddy. Sorry, that's my dog again. So we're using Oklahoma City and the Lakers. That's the 60 and the 45. So Oklahoma over the Lakers. I don't want to just write LA due to the Clippers. Make sure that you can tell what we're talking about. So Oklahoma was the 60. The Lakers were the 45. Excuse me. Draw. Well, 15 goes into both of these. 60 divided by 15 is 4. 45 divided by 15 is 3. So the ratio of Oklahoma to Lakers wins is 4-3. What this means is every 4 games Oklahoma wins, we can expect the Lakers to win 3 games. Now, this is based on real world data, so it doesn't mean it has to be consistent moving forward. It just says that so far, that's what happens. And maybe we can expect that. It depends on how significantly accurate it is, how statistically accurate it is. But that's not something we need to get into. Hold on, buddy. I'll let you out in a few minutes. You got to go that bad? Okay. Give me 1 minute. Sorry, class. All right. Now let's do B, and then we'll move on to the next type of example. So find the ratio of the number of games won for the San Antonio team to the number for the Clippers. So that's the other LA. You got to make sure you're not just focused on the LA, because you might, let's use the Lakers again, 45, and we're done. Nope, that's wrong. Wrong. San Antonio to the Clippers. So I'll do, is SA good enough? San Antonio, looks like it. Over the Clippers, CL for Clippers. San Antonio number is 58. The Clippers number is the 56. And we're not going to be able to reduce this very much. 2 is the only thing that's going to go into them. So I'll show that. There we go. 2 will go into 58 29 times. 2 will go into 56 28 times. So for every 29 games San Antonio has won, that means the Clippers won 28 games. That's just a nice reason to reduce fractions, to get smaller numbers, more manageable numbers. All right. And let's do 13, A and B. And then we'll call it. So a poll conducted on TV viewing preferences, excuse me, from a selected population produced the results shown. Numbers, musical, drama, comedy, mystery, and suspense, sports. Find the ratio of the number preferring comedy to the number preferring drama. So those are the 2 numbers we need to rip from this pie chart. So we're doing comedy over drama. The comedy number being the 525. The drama number being the 890. They both end in a 5 or 0, which means that 5 will go into both of them. Let's see, 5 will go into 525. That's a 105 times. Okay. And then 5 will go into 890. Let's see, that's a 1. That's a 7. Then an 8. Yes, 178. $105 and 178. Well, they end in 5 and 8, so 5's not going to go in, 10's not going to go in, 2's not going to go in because that's an odd. Does 3 go in? 1 plus 7 is 8, 8 plus 8 is 16. 16 is not divisible by 3, so 3 doesn't go in. 7, 40, 38, that's not going to go in. I am fairly confident that that is reduced as much as possible. You might take longer to reach that level of confidence, but that's the ratio of people that prefer comedy to drama. Now they say B, find the ratio preferring musical to mystery and suspense. Now be careful with the word and. That could actually mean that we're going to use multiple categories, but mystery and suspense is just one category. So there could be a problem that said compare musical to those that preferred comedy and drama. And then you'd add the 525 and the 890. We're not doing that though. So musical, we're doing musical over mystery. I'm just going to write the mystery part, MY. Mystery, suspense, kind of the same thing. So musical, that was 194 people. Mystery and suspense, that was the 368 people. Now those numbers are both even, which means we can divide them by 2. Half of 194 is 97 over half of 368. Well, that's going to be 164, right? No, 184, excuse me. Why did I say 160? 184, because half of 36 is 18. 3 is not going to go in the top. 5's not going to go in either. 7's not going to go in either. 11, nope. 13, nope. Fairly confident that that is the answer. Is 97 prime? 97 might actually be prime. All right. So that is ratios. There's not a lot of complicated math in the ratios. All it was write a fraction out pretty much, reduce if you're able to. In my opinion, there is nothing new in this section with the exception of pay attention, which is not really new, and then problem 10 with the mixed numbers. This is the only complicated problem out of the whole section in my opinion. I know it's an opinion, but that's why we went kind of quick through this section. So we have now finished 3.8, 3.9, and 3.10. So 3.8, 3.9, and 3.10 will be due next class by midnight. So for my Tuesday, Thursday class, that's the 16th. I'm actually going to give you all a couple extra days due to that power outage, due to having to do this a little bit late. I'm going to give y'all until, I'm just going to give everybody until the 20th actually. So my Monday, Wednesday, and my Tuesday, Thursday classes, I'm going to give you until April 20th, 11:59 p.m. There we go. So those 3 sections are going to be due on the 20th. I'm going to adjust those homework dates for everybody. This lecture will be in Canvas in just a few minutes, well, 15, 20 minutes. And besides that, we only have 4 sections left of Chapter 3 to cover. I do want to cover those as soon as possible, so we're going to get those done over the next 2 classes, hopefully, 3 if we have to stretch it out. And then after that, we're just going to use class time to kind of review, to go over some topics, some important topics, things that are going to come back, et cetera, et cetera. Besides that, have a good day, and we will see you next time on the internet. end.